Dear students, today I am going to explain the very important process of electrolysis. So what is electrolysis? Before going to understand the electrolysis, we need to understand the term electrolysis is popularized in 19th century by Faraday. It is the process to study the chemical reactions to get pure elements. The decomposition of ionic compounds into ions or elements by passing electricity. Acidified water or sodium chloride solution, if you take that electrolyte in this vessel, that acidified water or sodium chloride solution decomposes into elements. Here, the electrolysis process carried out in a vessel called electrolytic cell. This is electrolytic cell. This electrolytic cell contains two electrodes. One is cathode and another one is anode. Cathode is minus and anode is positive electrode or anode, positive electrode. Generally, these two electrodes taken as metals, taken from metals or metalloids or graphite. The electrolyte, here the solution is electrolyte, we call electrolyte. The electrolyte is in solution state or in fused state or molten state. The electrolyte contains ions when we pass the electricity through that electrolyte. So here, if you pass the electricity through this electrolyte, cations, that means positive ions in the solution, move towards the cathode and takes electrons from the cathode. That means the cations gets electrons at cathode. It is gaining of electrons. Gaining of electrons is reduction. Reduction is occurred at cathode. Now comes to the anions. Anions move forward to anode. Then anions release electrons at anode and oxidation is happened at anode. What is important thing, if the gas is formed at cathode, it is released at cathode. When a solid is formed at cathode, it is dissolved or liberated at cathode. Similarly, if anions gets into atoms at anode, it is released. If the gas is formed at anode, gas is released. If any solid is formed at anode, it is dissolved at the anode. Now let me explain, this is the electrolysis process. Let me explain the Faraday's laws. Faraday's laws are very important. So Faraday's laws, we have two laws. One is Faraday's first law of electrolysis. The amount of substance deposited or dissolved or liberated at an electrode is directly proportional to the quantity of electricity passed through the electrolyte during the electrolysis. It is mathematically represented by M is directly proportional to Q. M is mass, Q is quantity of electricity. So M is directly proportional to, we know that Q is equal to C into T. C is current in amperes and T is time in seconds. So therefore M is directly proportional to Ct. If you remove the directly proportional, we get M is equal to 1 constant, proportional constant and Ct. Here I am taking proportional constant is E. In somewhere we take Z also. So M is equal to ECT. E is electrochemical equivalent. So this is known as Faraday's first law in mathematical form. M is equal to ECT. But E, electrochemical equivalent, is equal to capital E by F. Capital E is chemical equivalent or equivalent weight divided by F is Faraday constant or Faraday. So therefore, if you substitute E value in the above equation, we get M is equal to, in the place of small e, we will substitute E by F. So E CT by capital F. It is another form of Faraday's first law. But E is equal to, E is equivalent weight. Equivalent weight of the any atom is equal to atomic weight by valency. Here A is atomic weight, Z is valency. If you substitute E by E is equal to A by Z in the above equation, we get another form. M is equal to ACT by FZ. And what are the in the equation? Where M equal to mass of substance, A is equal to atomic weight, E is equal to chemical equivalent. Not electrochemical equivalent, is chemical equivalent, and C is equal to current in amperes, T is equal to time in seconds, and Z is equal to valency, and F is equal to Faraday. 1 Faraday equal to 96,500 coulombs. Very important, coulombs per mole. Next, Faraday's second law. So it is very similar to first law. Here, if the same quantity of electricity passed through different electrolytic cells which are connected in series, the mass of the different species deposited or liberated or dissolved at electrodes are directly proportional to their chemical equivalents or equivalent weights. Suppose it is mathematically represented by M1 is to M2 is to M3, masses of substance at different electrodes. So M1 is to M2 is to M3 is equal to E1 is to E2 is to E3. Chemical equivalents, equivalent weights, the ratio of equivalent weights. Or we can say M1 by E1 is equal to M2 by E2 is equal to M3 by E3. So this is mathematical form of Faraday's second law, where M is equal to mass of the substance and E is equal to equivalent weights of the substance. How can you find equivalent weights? Equivalent weight is equal to atomic weight divided by valency. For any substance, for example, acid's equivalent weight is equal to molecular weight by basicity of acid. So different substance have different formulas, but standard formula is weight by valency is the equivalent weight. And let me explain this second law with diagram. Look at this diagram. We have three electrolytes, electrolytic cells. Three electrolytic cells connected in series. The same amount of current is passing through all these three electrolytes. In the first electrolytic cell, we have acidified water, is the electrolyte. In second electrolytic cell, we have copper sulfate solution, is electrolyte. And in third electrolytic cell, we have silver nitrate solution. We have different electrolytes, but we are passing same amount of current, all these electrolytic solutions. What Faraday's second law says? In the first cell, at platinum electrode, here is at cathode oxygen is released, at anode hydrogen is released. So the mass of oxygen or hydrogen M1, take M1. And copper sulfate solution, at cathode copper is added to that electrode. So therefore the mass of the copper is M2. Here silver nitrate solution, silver formed at electrode. So therefore mass of silver is M3. What Faraday says, M1 is to M2 is to M3 is equal to equivalent weights of the substance which are formed at electrodes. Equivalent weights, the equivalent weight of oxygen, the equivalent weight of copper, the equivalent weight of silver. So therefore M1 is to M2 is to M3 is equal to E1 is to E2 is to E3. ఆఫ్ చేశాను.